The first element of a new setup is removal of the existing setup. All components that will not be used in the next setup should be identified, removed from the machine, and stored in an orderly fashion. The container used to store this material should be well marked with a specific job number. If you are using rigid-type coolant lines, they should be removed. If you are using flexible coolant lines, leave them in. They can be easily positioned out of the tooling area and repositioned as they are needed. Next, all form tools and tool holders should be removed from the machine. Some of these holders may be required on the next job and should be set aside with the appropriate tooling. These holders can be identified by number on the job layout under the Operations column. Return tool holders that are not required to the tool crib or your supervisor. At this point, all attachments that will not be used on the next job should be removed. Attachments that are required will be identified on the job layout under the Operations list and under the Tools Required list. Upon removal of attachments used on the previous job, the required attachments for the new job should be mounted. Specific mounting instructions for all standard attachments is beyond the scope of this tape, but will be covered in future tapes on attachment installations. Two exceptions for attachment mounting at this time are the stationary head burring attachment and the transfer and slotting attachment. If you are using either of these attachments, do not mount at this time. The next step will be to change cams for both the end-working and cross-working tools. We will start by removing the tool spindle cam carrier on the right end of the machine. First, remove the burring spindle, chuck opening and closing linkage, the lever and both springs from the burring attachment. Always grip the springs with a rag. Loosen and remove the 716-14 hex bolt that retains the chip conveyor ratchet lever. Remove the chip conveyor spring and swing the ratchet assembly toward the front of the machine so it rests in the pan. Using the cam lever rod, push each cam lever forward and position the cam lever stops on the tool spindle cam lever support bracket. This will position the cam levers away from the cams, allowing the cam carrier to be removed. With a 1 1/8 open-end wrench, loosen the tool spindle camshaft bolt, turning it counterclockwise until the threads are disengaged. With your right hand, support the cam carrier from the center while removing the camshaft bolt with your left hand. Be prepared to support the weight of the cam carrier as it will drop when the camshaft bolt is retracted approximately 14 inches. Remove the cam carrier from the machine. To remove the front cam carrier, first remove all springs from the cross-working cam levers. Loosen the 3/8-16 square head set screw that retains the first position positive return lever fulcrum pin. Remove both the fulcrum pin and lever. With a 1 1/8 open-end wrench, loosen the front camshaft bolt by turning it counterclockwise. With your left hand supporting the cams, retract the camshaft bolt and remove the cam carrier. We will start changing cams on the tool spindle cam carrier. First, we must remove the cam carrier nut by tapping it in a counterclockwise direction with a brass rod. Set the cam carrier on end and proceed to remove the cams and spacers. In many cases, the spacers may be used for the next job. Once the cams have been removed, it's time to review the job layout for the cams required on the next job. Looking at the layout under Cams Used, we can find the cams identified by number for each particular end working position. The end working cams will be identified in the top half of the operations box for each particular position. On this job, we see that a broaching operation will take place in the fourth position. A positive return cam assembly is called out above the operations box, as well as in the Tools Required list. From this positive return assembly print, we see that two special spacers will be required. The first, 5080-24-16, is between the broaching cam and the positive return disc, and the second, 5080-24-15, is between the positive return disc and the second position cam. To clarify specific cam position on the cam carrier, we can identify the order of position by looking at the lever position from the right end of the machine. Noting that the cam carrier nut is positioned toward the front of the machine and that all numbers stamped on the cams face the front of the machine, the order in which the cams must be placed on the carrier is the opposite order they appear left to right on the machine. That is, the first cam to put on is the third position cam. Then we use a standard 5080-24 spacer. The next will be the second position cam, which we will follow with the special spacer noted on the positive return assembly. Next, we place the fourth position positive return disc on the cam carrier with the disc facing toward the threaded end of the cam carrier. Next, the other special spacer, 5080-24-16, is placed on the positive return disc. The fourth position broaching cam is followed by a standard 5080-24 spacer and then the first position cam. Our machine is equipped with a chip conveyor. This requires two special spacers between the first and fifth position cams and the chip conveyor cam. These 9/16 wide spacers are supplied with the chip conveyor. The last cam to go on will be the fifth position cam, which in this case is the burring cam. Once the cams have been placed on the carrier, replace the cam carrier nut and fasten tightly with a hammer and a brass rod. The tool spindle cam carrier is now ready to be mounted on the machine, and we will now change cams on the front or cross-working cam carrier. First, we must remove the cam carrier nut by tapping it in a counterclockwise direction with a brass rod. Remove all existing cams and spacers. The spacers will be used on the next job. Next, we will mount the cams for the next job. Once again, these cam numbers can be found on the job layout. The cross-working cams will be identified in the bottom half of the operations box for each position. Once the cams for each position have been identified and procured, we are ready to begin. The first cam to be mounted will be the third position. Note that all cams mounted on the front cam carrier are done so with the stamped numbers down or facing away from the threaded end of the carrier. This is the direct opposite of the tool spindle cam carrier. Place a spacer 5080-74-19 on the carrier and then the second position cam. This is followed by another spacer and the fifth position cam. Finally, we add one more spacer, followed by the first position cam and the first position positive return cam, which is supplied with the machine. When all cams are in position, we must tighten the nut with a hammer and brass rod. The mounting order for the front cam carrier is third position, second position, fifth position, and followed by the first position and first position positive return cam. The fourth position cross slide is an optional attachment. Its cam mounting procedure will be covered in a separate tape dedicated to that attachment. Both cam carriers are ready for our job and should be remounted on the machine. We will start with the tool spindle cam carrier. With the machine at half index and the cam levers supported by the stops in a forward position, position the carrier into the machine. Note the locking nut and cam number should be facing the front of the machine. Line the drive slot in the cam carrier with mating slot in the camshaft extension and insert the cam lever bolt through the carrier. Tighten the cam carrier bolt with a 1 1/8 opened end wrench. Remove the cam lever stops so the levers ride on the cams. Reassemble the chip conveyor ratchet lever by positioning it over the fulcrum pin and securing with the 716-14 hex bolt. Replace the chip conveyor spring. The tool spindle cam carrier is now in position. At this point, we must refer back to the job layout and determine block location for each end working lever. From the layout, under the block location column, we see that the block location on all the end working tools is 1.0. Check all tool spindle cam levers and adjust the block location accordingly. To change the block location, take a 1/2 open end wrench and loosen the 516-18 hex nut that locks the cam lever link end. Reposition the link end so the 0 mark lines up with the required graduation on the cam lever and retighten the locking nut. We will now install the front camshaft. With the cam lever springs removed, push the cam levers forward. With the cam carrier nut facing the right end of the machine, position the carrier in line with the camshaft bolt. Align the slots in the end of the carrier with the mating tang in the camshaft sleeve. Push the cam lever bolt through the carrier and start the threads by hand, turning in a clockwise direction. Tighten the bolt with a 1 1/8 open end wrench. Reassemble the first position positive return lever and fulcrum into the cam support cap and tighten the 3/8-16 square head set screw. Replace all springs on their appropriate cam levers. The front camshaft is now in position, and we must again refer to the job layout and check for appropriate block locations. Note the order of cam levers from left to right on the front of the machine is as follows: third position, second position, fifth position, followed by the first position. At this point, both camshafts have been installed and the machine is at half index. This means that all cams are on the low point and the slides and spindles are in their retracted position. To ensure there will be no interference through the working portion or high point on the cams, we must manually take the machine through one cycle and back off any turnbuckles where necessary. With the starting clutch engaged, turn the hand wheel clockwise. The machine will begin to advance into the work cycle, and the tooling will start to advance. The advance of each station must be monitored closely for interference. In many cases, a cross-working position will bottom on its dead stop before the advance of the cam is completed. You will immediately notice this as the hand wheel will jam. The workstation causing the jam must be identified, and a turnbuckle adjustment will have to be made to retract the forward approach and allow it to advance through the work cycle without binding. To back off any workstation, use the turnbuckle wrench and turn the required turnbuckle counterclockwise. Continue advancing the machine through the work cycle until there is no interference through an entire cycle.